Our fifth presenter today, excuse me, is Ronak Mehrabi. Ronak is going to be telling us about her work in bio-mediated soil enhancement. She comes to us from the Department of Civil, Structural, and Environmental Engineering in the School of Engineering and Applied Sciences. She's a strong advocate of climate change and cares deeply about our planet. And she is a foodie that cannot live without cheese. Ronak, when you're ready, set, pitch.
I'm a civil engineer, and my job is to ensure your safety by designing stable structures. As you know, the stability of all types of structures starts from the soil beneath them. This soil could be naturally dense and stiff, such as sea cliffs or the walls of canyons and valleys. But this soil could be naturally loose and wet. Imagine a pool packed with ping pong balls and water. This example best represents the composition of a loose, wet soil. Now, think what happens if you tap your foot into this pool packed with balls and water. Yes, your foot will definitely sink into it. This experience is similar to what happens to structures during liquefaction, a geological hazard that is responsible for large infrastructural damages during earthquakes. In liquefaction, the loose wet soil acts like a fluid rather than a solid due to earthquake shakes. As a result, the structures collapse and sink into the soil. The current way to mitigate liquefaction is mixing the soil with chemical cement to make it as strong as concrete. However, the chemical cement is costly, and the manufacturing of it is responsible for emission of up to 5% of greenhouse gases around the world. But we always can come up with an innovative and better design and solution to prevent the natural hazards by taking the inspiration from the smartest engineer around us, the nature. In this regard, my research investigates the use of a natural sustainable cement called calcium carbonate. Calcium carbonate is a mineral that is naturally created on Earth or in fresh water by means of microorganisms and through some chemical reactions. This process can be synthesized in our laboratory by mixing the soil with a specific bacteria and specific chemicals and letting the chemical reactions happen over a few days. The product is calcium carbonate, which is our natural cement. Now, remember the example of the ping pong balls as the grains of our soil. When the natural cement is produced between these grains by help of the bacteria, this cement attaches the grains or say balls together as a glue. This glue-like connection prevents the balls or grains, prevents the movement and sliding of these balls or grains relative to each other. As a result, we have a solid concrete-like soil that withstands earthquake shakes and is reliable to build our infrastructures on. Now you can see where I found the biggest motivation to carry out this research. Inspiration by nature and sustainability. My goal is to promote and advance the use of processes found in nature to solve engineering problems related to Earth structures. After all, I'm a civil engineer and I should put your safety first. Why not to do it with the help of our mother nature? Thank you.